next we have Paul, who's going to give us a good presentation here. There's your mic.
Oh, is it working? Yeah.
Yep. Great.
Oh, clicker. Thank you so much. Hi, everyone. I'm Paul Litvak. Quick story. When I was a freshman in college, I went to a talk by Benoit Mandelbrot, who you might know is like the inventor of the fractal. And it was like this math department talk, and I thought it was going to be like a lot of really cool art. And he got up and he goes, "There will be no pretty pictures in this talk." So there will be no pretty pictures in this talk. Sorry. Okay. So I'm talking about building an evidence quality engine for science. So what is that? Did I press the right button? Oh no. Yes, okay. So a few words about me. So I have a PhD in behavioral decision research. I worked as a data scientist at a bunch of tech companies. I started a company and then it failed, and then I started this nonprofit institute. Both in my graduate career and also in the startup, I was basing that work on research that it turned out did not replicate, and that kind of woke me up to the scope of this problem in academia and just like how much bad research there is. And so how do you know whether or not research is good? One way to know is what's called a replication. So you take a study, you rerun it again, and then you see basically whether or not it actually holds. And that has become a kind of like gold standard for good science. So the problem is that a lot of research actually does not replicate. So some scary numbers for you here. So there was some recent work in psychology. They found that like 50% of the papers, when they ran them, actually didn't work the second time. In economics, same problem. At least 35%, maybe more, depending on how you count it, also don't replicate. And even scarier, in cancer studies, you find an even higher proportion of studies that actually do not work, and that actually sets back research by many months and years. And some of that is fraud, some of that is poorly done research, some of that is academics who are trying to get a positive result and then will like manipulate the data in sort of like subtle ways. But if we can sort of like identify and figure out which studies actually will replicate and predict which ones won't, then potentially we have a way to kind of like grade the quality of evidence, and that is what I'm trying to do. So I've built this system that is basically like the first step in trying to assess whether or not a given research claim is actually like legitimate or not. And to do that, what we have to be able to do is, number one, we have to turn like scientific PDFs into structured data, basically to convert them into like signals of quality. So like, do the numbers add up? Like, does the population that they're using make sense? Do the results kind of like generalize? Like those kinds of questions. And so we can take a scientific PDF, which is like a super messy format, multiple columns, like tables, etc., and then we need to be able to like basically turn that into these kind of like structured signals. And then once we have that, then basically we can train an ML model to try to predict which studies will replicate and which don't as a function of all of these different indicators of quality. And I'm starting in the kind of like the field of psychology and social science more broadly because actually there have been a lot of replication studies that have happened in the last like 5 years. It's sort of like at the forefront of this kind of scientific reform movement. So there's like thousands of these replications now, some of which worked, some of which didn't, and now we can sort of see, can we predict which ones work and don't? So why is this unsolved? Well, one reason that it's been unsolved historically is because, as I was saying, scientific PDFs are like super visually complex. They're multi-columns, there's equations, there's footnotes, there's like data tables that are non-annotated, like very hard to extract that information in an accurate way. There are lots of tools out there that can get you kind of like part of the way there. You can use kind of visual LLMs, you can use Mistral, like open source models. There are some specialized packages that exist for this. Robyn is kind of like one of them, but nobody has like built a kind of full end-to-end pipeline. Like these systems exist. If you want to use something like Mistral, then what you're doing is you're like literally chopping up the PDF and then like sending it page by page and then kind of like collating all that information together. So no one has built like a really good end-to-end pipeline that will say, okay, let's like go from paper into structured data. And that is the system that is sort of like built. So it's got these different steps. You've got a kind of a layer to basically just like turn the section into the paper into text. You've got basically like an LLM layer that then takes that text and then turns it into kind of like structured data, like these are the hypotheses, these are statistical tests, these are the different ways that like the data is interpreted, and then we use Gemini to actually look at the individual tables and extract the information from there, and then once we have all that information, then we can calculate all of these different signals of quality. So This exists right now as a Docker container, basically. You've got, and has all of these different elements kind of like embedded inside of one container. That container then goes on to Dispersed, and then I'm able to basically like send PDFs to that container and then get all of this information back from it. And so there's a web interface at Evidence.Guide, which is sort of like a web interface for mostly for researchers right now who can upload sets of papers and then get this structured data back for analysis. And so we're using Dispersed for just this kind of like the core element of this, just this kind of like PDF processing element. And so, as I was saying before, we have this ground truth data from all these different sources of replication studies with known outcomes. We have all these different kinds of signals that we're then calculating. So, like things like, do the numbers add up? Like, given the sample size and the means and the standard deviations, like, are these numbers actually possible? You'd be shocked to know that in a lot of cases you have literally impossible numbers in papers that are indications of perhaps fraud, but at the very least carelessness. Then you've got kind of like, what is the sample size? Like, how is there evidence of publication bias? Did people pre-register? Like, did they, before they ran the paper, did they say like, oh, okay, this is the thing that I'm going to test? So there are all these different kind of like signals that you can aggregate together and then use that to predict whether or not something is likely to replicate. So yeah, so basically right now we're processing for this initial model building on the order of about 10,000 papers, and the LLM extraction can, through batch mode, can actually process many hundreds of papers per hour. It seems like a small number per hour, but there's so many like iterations to basically like extract all the information from papers, not just like one round of LLMs. It's like this whole kind of like complex pipeline. So it can take minutes, like 10, 20 minutes to process a single paper. And then once you have that, then you're calculating these quality features. Okay, so where is this going? So basically step one is to kind of like build this model. Then once we build this model, then the idea is to build these kind of like living meta-analyses, these kind of like updating documents that tell you what the state of evidence is for different questions in the given field. Psychology is kind of interesting. What's much more interesting is other areas where they're making very important decisions on the basis of these findings, right? So in developmental economics, they're running all these randomized control trials, and for that, they want to know. You want to know basically like which experiments are valid and which ones are not. For clinical medicine and public health, even more important, there are these kind of systematic reviews that are built kind of one at a time. But there's many different medical questions that that the evidence is like very murky. Like if you go online, you're like, oh, do vaccines cause autism? You can like find a bunch of papers. Like, does it really or not? Like, there's not really like a good canonical source that will tell you like, okay, given all the evidence, actually no, absolutely it does not. So getting to that point where we can process hundreds and thousands, if not millions of papers into these kind of like living evidence documents and then making that available to the public, to policymakers, et cetera, anybody who's trying to make decisions based upon scientific evidence. So that is the goal. And yeah, that's all I have.
Great, good one. So we've got a few minutes for questions for Paul. So what do you think the actual impact of this will be on the research cycle itself? So do you hope to impact that cycle, or is this really a post facto?
Yeah, that's a really good question. So there's like a lot of people that are trying to build different tools for kind of like helping researchers before they kind of like publish. And that's where a lot of the kind of like the field has been kind of focused. The kind of idea of like retrospective analysis, or like kind of like looking at things after the fact to see like how strong the evidence is, that's an area that's been sort of like historically underinvested in. And there's a lot of reasons for that. I think a lot of researchers don't want to ruffle feathers and go back and like kind of muck around in old research and be like, oh, it turns out this thing is actually kind of illegitimate, and like my colleague like fucked up. Like no one really wants to say that. And so there needs to be like some sort of like layer outside of the kind of traditional structure of academia in order to basically like kind of like hold the record straight, basically.
So you're viewing this as you're going to stay outside of that system, auditing that system?
Yeah, that's
right?
the idea. Yeah.
Yeah. Okay. You'd probably mess with that pretty severely if you were inside that.
Yes. And I think eventually there are ways in which you can use a system like this to kind of upend, disrupt the existing kind of like publication industry. I think.
Cool. Well, we've got time for a question
Sure.
from the audience if you.
How many people are going to be so mad at you?
That is a good question. No one's mad at me yet, but I think people will, for sure, academics will be mad at me, and like lots of people who are like, the producers of that research. And it's certainly the case that other kind of like anti-fraud people who have come out with like issues in publications, they get a lot of flack in the field. Sometimes they get sued for libel. So yeah, I need to buy some insurance before I go out and start talking about this stuff publicly. Thank you so much.
Yeah, Poliani and a lot of philosophy of science people point to tacit knowledge for this problem.
Mm-hmm.
Knowledge which isn't able to be communicated linguistically or can be communicated poorly linguistically. Is this measurable? Do you believe that this is the case in sort of these poor replication
Ooh.
rates? Yeah,
Yeah.
what's going on? How's that relate?
Yeah. That's an awesome question. So I think in some cases the tacit knowledge is part of it, where like there's not enough information in the paper itself to like understand how to replicate the given finding, and there's some kind of like special sauce. So that there's probably like a minority of cases where that is the case. It's certainly the case now that like as this problem becomes more acutely understood, there's a lot more emphasis on trying to like include all of the data, all of the code, like all of the other kind of like supplementary information that went into creating the finding to make it easier for people to kind of like do these replications. But to date, what's happened, I think, oftentimes is like somebody will fail to replicate and they'll be like, oh, you didn't realize that you needed to do this thing, you need to stand on one leg, blah, 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 blah. But it's kind of disingenuous because they're not saying that beforehand. They're saying it after the fact as a way to explain the fact that their like finding doesn't really work. So it can be a kind of a cop out is the short answer.
All right, fantastic. All right, thanks very much.